Hello everyone, this is Mr. Underkoffler, and this is part 2 of the guided notes on determining a series of transformations, where we are going to start with number 8 and 9. They are open-ended problems that are after this first 7 multiple choice problems. Okay, so let's get started. Problem number 8. Follow along with me here as I read the problem out loud. I will do this one with you, and then you'll end up doing number 9 on your own. Okay, triangle RST has vertices, here they are, R, S, and T. You can read them. After a series of transformations, R prime has coordinates -4 and 6, and T prime has coordinates -4 and 2. Part A. Using the coordinate grid provided, find the coordinates of S prime. Okay, so what we're going to do here is let's do the logical thing. Let's graph the original points of R, S, and T. Okay, so do this with me here. R is 6, -1, so 1, 2, 3, 4, 5, 6, and down 1. S is 5, -5, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There is S. And finally, T is 2, -1, so we're going to go right 2 and down 1, right there. Okay. Let's go ahead and connect those dots and draw our line segments to make our triangle. Something like that. All right. Now that we've done that, let's graph the R prime and the T prime that were given to us. R prime is now -4 and 6. So left 4. Did I count correctly? 1, 2, 3, 4. Yeah. And up 6, 1, 2, 3, 4, 5, 6. There's R prime. And T prime is -4 and 2. Okay, 1, 2, 3, 4, 1, 2. All right. Now, I would go ahead and draw the line segment that connects those two dots. And the question is, what are going to be the coordinates of S prime? Okay. Well, we kind of need to figure out what type of transformation was this? Was this a reflection? Was it a rotation? Is it a dilation? Well, it doesn't look like it's a dilation. From T to R, it was 1, 2, 3, 4, and now it's 1, 2, 3, 4. So it's not a dilation because the line segment RT or R prime T prime is congruent to RT. So not a dilation, but it does look like to be a rotation because if it was a reflection, it wouldn't be going up and down. It'd be going left and right still. Yeah, so probably not a reflection over the x-axis or the y-axis. Now, reflections over the line y equals x could do some interesting things, but we're not going to go crazy with y equals x. This surely looks like a rotation to me, a 90-degree clockwise rotation. So with that in mind, we could kind of count how far it was to get from R to S. So it was 1, 2, 3, 4, right? 1, 2, 3, 4 down, and then 1 to the left. So when you rotate 90 degrees counterclockwise, what used to go up and down is now going to go left and right. So instead of going 4 down, I'm going to go 4 to the right, which actually puts me on the axis conveniently. And instead of going 1 to the left, I have to go 1 down. And I can go ahead and draw that point. Now, does that look like the right spacing here? Right 4, down 1, down 4, left 1. Yep, that seems to match up. And now I can go ahead and connect those dots. Not really sure why I have them dashed here. You could just keep them solid. And yeah, that appears to look like, yes, they're congruent triangles. They look, and you know what? You could always take your paper and rotate it 90 degrees counterclockwise to make sure you know what the orientation should look like. of the original figure when you rotate it 90 degrees counterclockwise. So, and it looks like this, what I drew. Okay, so let's write down those coordinates. That would be 0, comma, let's see, 1, 2, 3, 4, 5. So 0, comma 5, write that down. And there you go. Okay, so now that we have done that, part B, describe the series of transformations that maps RST onto R prime, S prime, T prime. So this is not just a 90-degree counterclockwise rotation, because if I do a 90-degree clockwise rotation about the origin, in fact, can I show you that? No, I cannot, because I have this locked on my screen. But if I would do that, that would put it from quadrant 4 into quadrant 1. And it's not just there. It's over here in quadrant 2. So if I would do a 90-degree clockwise rotation, then T, instead of being right 2 and down 1, would have been up 2 and right 1. That's where T would have been. Well, now it's way over here. Likewise, R, instead of being 1, 2, 3, 4, 5, 6, and then down 1, would have been up 6 and right 1 if I do a 90 degrees counterclockwise rotation. So if I now figure out T prime was here and R prime was here, but now they're over here, that would be a translation 1, 2, 3, 4, 5. And let's double check 1, 2, 3, 4, 5. Yes. So there you go. It would be a translation 5 to the left. So now I can go ahead and write this down. This is a 90-degree counterclockwise rotation about the origin. And yes, you have to write down what the center of rotation is whenever you describe a rotation, because every once in a while you could have a rotation where the point of rotation is like, letter S or letter R or letter T. So this was 90 degrees counterclockwise about the origin, followed by a translation 7 units left. Okay, and write that down if you haven't already. That would map RST onto R prime, S prime, T prime. Now, you might be wondering, Mr. Underkoffler, could there be more than one answer? Could I do a 90 degrees counterclockwise rotation about like point T and then do a translation 1, 2, 3, 4, 5, 6 to the left and 1, 2, 3 up? My answer is yes, you could, but that would be a lot more complicated. So if you want to work smarter, not harder, then stick to the center of rotation being about the origin. That's what I would recommend. But there are other ways of doing it. So some of these problems, well, there's only 2 here that we're doing, 8 and 9, can have more than one answer. Or not more than one answer for S prime, but, well, maybe they could. But I was speaking about more than one answer for part B. Okay, now that I've led you through problem number 8, let's have you try problem number 9 on your own. So hit pause on the video. Do all the work for 9A and 9B. Use the graph things on the graph. Take your time. And then once you're done, hit play to see how you did after you've done both part A and part B. Okay, have you already done 9A and 9B? If not, hit pause now and finish doing this on your own. Because here I go. All right, I'm going to go ahead and graph the original figure, J, K, L, and M. And unfortunately, my dots are way down here, and yet my graph is way up here. I wonder if I can just... Oh, yes, I can. I can move them up, so that way I can make it closer to the original problem. Okay, yay for me. So J was -2, -1. K was -1, -1. L was -1, -3. Oh, I like these horizontal and vertical lines. That's really nice. And then finally, M, not going to make a horizontal vertical line. Well, it does make a horizontal line here from L to M, is -3, -3. And if I connect those dots, I do get a nice little... This is not just a quadrilateral. This is actually a parallelogram. So that's pretty cool, because we have the top JK and LM are parallel to each other. So this is a parallelogram. All right, now what was I told about J prime, K prime, and M prime? I'm going to go ahead and highlight them if I can and get them higher up. They are these coordinates. Okay, so J was -4, -2, or +2. So I go 1, 2, 3, 4, up 2. Is that where your J prime was located? Double check your work right now. K prime was -2, +2. So that's here. M prime was -6 and 6. And I'm going to connect those dots. Not quite completing the entire parallelogram right away, but that puts it right about there. Okay. This is not just a reflection or rotation. This is a dilation. And here's how I know this. JK, if I can use my highlighter here, was only one space originally long. Now it's 2 long. And JM used to be 2 high and 1 wide, if you would go like down 1, left 1. Well, now it's up 4, left 2. So it appears that things are double the amount of what they used to be. I'm kind of jumping ahead to part B. This is the thought process I would go through. But to figure out where L prime is, it's actually not that hard in my personal opinion, because you probably noticed how L makes a perfect right angle with the line segment from KL to LM. So instead of going down, I'm going to go up. And instead of being, well, actually, it would still be to the right of M, wouldn't it? So that should be right there. So that way I have a nice vertical line and a nice horizontal line from M prime, because that's what I should have to make this a parallelogram. So there you go. All right, so what were those coordinates for L prime? That was -2 and 6. Now, to describe the series of transformations, as you heard me talk about out loud, it appears things have been doubled. JK used to be 1, now it's 2 long. In fact, we can now count KL to K prime L prime. It used to be 2 tall, now it's 4 units tall. You could even check out LM. Now it's 1, 2, 3, 4 long. It used to be 2 long. So it appears things have been doubled. And you also could have checked the coordinates. Like, let me show you what I'm talking about. The coordinates here. J was -2, -1. Now it's -4 and 2. Now, I know the y coordinate's now positive, but there definitely appears to have been a multiplier of 2 for the scale factor. But it's not just a multiplier of 2, because it's now up in quadrant 2 instead of down in quadrant 3. So you have to figure out, is this a rotation or is this a reflection about the x-axis? Well, if I rotated it 180 degrees, well then J and K, J wouldn't be on the left anymore, and K wouldn't be on the right. If you don't believe me, go ahead and rotate your paper 180 degrees, and you'll see what I'm seeing. Furthermore, the diagonal, which I'm going to highlight in blue here, of JM would now be like slanted that way instead of slanted this way. So this is not a 180 degree rotation. It's not a 90 degree rotation. This is a reflection, because then you still have J on the left and K on the right, and they would be close to the x-axis, just like they were before. And further away from the x-axis would be LM. M would still be on the left, M would still be on the right, like you see here. So this is a 2-part thing. This is a reflection over the x-axis and a scale factor of 2. And honestly, the order shouldn't matter. If you double the coordinates and then reflect it, it's still going to end up being at the same place. So if you have this order flip-flopped, should not matter. All right, that is it. There is no problem number 10. So thank you for watching part 2. We'll see you next time.